Okay, so this is page 29, lesson A-12. We already started it last video. We did this page here, page 28. And today, before these examples together, I just want to talk about this growth competition. So if x is approaching infinity, then what's going to come in first place is exponential functions, like e to the x. Although they could have any base, like 2 to the x, 5 to the x, but exponential functions will win first place. Second place will be power functions. So that's like your typical like polynomial terms, like x squared would be a power function, x to the fifth, 9x to the seventh. Those are power functions. Those would come in second place. Third place would be logarithmic functions like natural log of x or really log of any base. And yesterday we talked about the graphs, and you'll want to think about this today, but we need to know the graphs of e to the x, e to the negative x, and natural log of x. Okay, so I'll just show you how to do this. So we've got the limit as x approaches infinity of this fraction here. So we're doing a limit. X is approaching infinity, so we're going to use growth competition. So I'm going to show you that right now. So you go equals limit as x approaches infinity, okay? And then you look at the top and you see which term wins on the top, okay? This is a power function. This is a exponential. So exponential functions win on the e to the x wins on the top. And then in the bottom, these are both power functions, but you just take the higher power. That one is going to win. Like if it's a competition between power functions, just the higher power would win. Okay. Now, we can't really simplify here, but as x approaches infinity, e to the x is going to win over this power function. All right. So, and if e to the x is winning, that means that so if you can, sorry, I'm interrupting myself, but if you can simplify here, guys, you should. But if you can't, then you think, okay, is the top outgrowing the bottom or is the bottom outgrowing the top over time eventually? And in this case, we've got the top outgrows the bottom. And if the top of a fraction is getting huge, then the entire fraction is getting huge. So this is infinity. Okay. Here's another situation with growth competition. So the limit as x approaches infinity of this fraction here. Okay. So then you go equals the limit as x approaches infinity, and then you just think about what term wins on the top, what term wins on the bottom, and then we'll go from there. All right, so in the top, so we got 3x, we got sine of x, and we've got negative 10. Okay, so I know it's between these two. This is actually a type of power function, or it's a linear function. But, okay, but sine of x, guys, sine of x, if you think about what sine is, it's the y-coordinate of a point on the unit circle. So sine will never, no matter what x is, sine of x can never go outside of -1 to 1. Okay, because you're on the unit circle. So the lowest possible y is -1, the highest possible y is +1. So this is going to be the winning term on top. And then in the bottom, you've got 4x to the 12th and e to the negative x. Now, with e to the x, guys, you do have to pay attention to whether x is approaching positive or negative infinity, and also whether it's e to the x or e to the negative x. All right, because e to the negative x looks like this, and x is approaching positive infinity. As x approaches positive infinity, e to the negative x is not winning. It would be, negative infinity, e to the negative x would be winning, but in this case, no, that one wins. 4x to the 12th. Now, if you can simplify, you do simplify. And so I'm going to go equals. And if you can simplify, guys, that means you need a limit in the next line. Okay, so on the top, I just have 3 over 4x to the 11th. Okay, and now you simplify as much as you can, and then you think about what is outgrowing what, the top or the bottom. So the top is always staying 3. The bottom is getting enormous. So if the bottom of a fraction is getting huge, then the whole fraction is shrinking. It's getting smaller and smaller, closer to 0. So in this case, we've got bottom outgrows top, in which case the fraction itself is just shrinking, shrinking, shrinking down to nothing, 0. Okay, so that's the answer here. So that's the answer, that's the answer. Now, if I just want to point this out, because we had these two situations that we just saw. X was approaching infinity, we did growth competition. In the first example, we got infinity. In the second example, we got a number. So since we got a number, which I'm just calling A here, this means we have a horizontal asymptote, y equals 0, which is the x-axis. All right, I just wanted to point that out. Okay, next. All right, so this is the limit as x approaches negative infinity. So equals the limit as x approaches negative infinity. And okay, what's winning on the top? If we were approaching positive infinity, then e to the x would win. But approaching negative infinity, think of the graph of e to the x. It looks like that. If you're moving further and further left on the graph, the y values are actually shrinking. They're getting smaller. So in this case, because x is approaching negative infinity, it's actually the top that, or sorry, it's actually this term that is winning. And then in the bottom, negative 8x to the 4th is winning. Okay, and so this is, so if you need to simplify, then you need another limit. All right, so this is negative 1 over 2x. Okay. And now I've still got a situation where the bottom is outgrowing the top. So I'm plugging in negative numbers, but they're still huge negative numbers. So the bottom outgrows the top. So again, that's 0. So for the graph of this one, we also have a horizontal asymptote at y equals 0. Okay, now just 2 more. The point of these 2 examples, guys, is that we can use the growth competition inside of radical and exponential functions. Okay, so the limit as x approaches infinity of this. All right, so x is approaching infinity, so I know I need the growth competition. And you may ask, what happens to the radical? It just stays there, but you'll just have a single term underneath it. So this is the limit as x approaches infinity. And okay, what's the winning term on top? X to the 6th, but I've still got the radical. So radical x to the 6th. Okay, what's the winning term on the bottom? X to the 6th. Okay, now we need to do some simplifying. So this is the limit as x approaches infinity. So the square root of x to the 6th is x to the 3rd. So it's x to the 3rd over x to the 6th. Now, can we simplify? Yes. Then we need another limit. And we simplify that. 1 over x to the 3rd. The bottom is way outgrowing the top, 0. Okay, one more. This is the limit as x approaches negative infinity. So we would still use growth competition. But this time, we're going to do it inside of an exponent. All right, so this is e to the, all right, so up here I'm going to have, because the exponent is x plus 2 over x. Okay. So which term wins on top? X. Which term wins on the bottom? There is just an x. Okay. All right, so can you simplify? Yes. So you need another limit. If you can simplify, you you need to open up another limit. So this is just e to the first. That's just e to the first. Guys, this is a constant. E is a constant number. It's 2 point something. 2 point. So sorry, e to the, all right, 2.71828. Okay, it's a number. There's no x with it, so that is the answer. It's a constant function. So this graph has a horizontal asymptote at y equals e, which is about at 2.718. Okay, there's that.